Hello. In this video, I'm going to show you a proof of this rule. The rule that says that if you see a product of terms, then the fractional uncertainty in the product can be obtained by adding up the fractional uncertainties of all the individual terms. This is not required by the A-level syllabus, but I'm sure many of you are curious. If I want to do 1.01 times 1.02 times 1.03, without using the calculator, I can immediately tell you that the answer is about 1.06. This is the exact answer, so 1.06 is pretty close. How did I do that? Now, if I write 1.01 as 1.00 plus the tiny difference of 0.01, and I do the same for the other two numbers, then when I expand the brackets, I'm going to get a 1 from this times this times this. I'm going to get a 0.01 from 0.01 times this, the 0.02 from 1 times 0.02 times 1, the 0.03 from 1 times 0.03, and I'm going to ignore all the other terms, because I know all the other terms are going to involve multiplying at least two small numbers, like 0.01 times 0.02 times 1, and all these numbers are going to be small compared to these three numbers, and that allows me to conclude that the answer is about 1.06. Basically, if you have three numbers and they increase by 1%, 2%, and 3%, then the product is going to increase by about 6%. The 6 coming from 1 plus 2 plus 3%. And this is what this rule is all about, isn't it? If you're still not convinced, then here is the more rigorous proof. What this line is saying is, if A increases by a small amount delta A and B by an amount delta B, then P is going to increase by an amount delta P. If I draw A from this bracket and B out of this bracket, I'm going to get this line. If you know your binomial expansion, then this line to this line is obvious. Now notice I've excluded all the higher order terms. This is because if delta A over A is a small number close to 0, then all the high powers of delta A over A are going to be negligible. I'm going to multiply up these two brackets, and this is what I get. Notice again I've excluded all the higher order terms, because I know they are going to be small compared to these terms here. So in this line, I hope that you can recognize that this is P, this is also P. So what is inside the bracket must represent the fractional uncertainty in P. And so I've shown the proof for you. I hope you realize now that this rule allows us to get only an estimation of the fractional uncertainty in P. But this estimation is pretty close if delta A over A and delta B over B, and as long as all the fractional uncertainties involved are small. That's all, folks. Ta-ta!